Welcome back to another thrilling episode of How to Do Stuff with Mr. Stevenson. Today we're going to be working on something called surface area. It is area. It's just finding several areas at once is basically the difference. Where we were just finding the area of one shape before, we're going to be finding the area of several. And here's a little illustration to show you. You recognize this as a cube, something you'd see like a dice or a sugar cube or something like that. And what we have here is and this cube has 3-inch sides, so everything is 3 inches around. So this side's 3, this side's 3, this side's 3. So we have every side is 3 inches. Now, if you take this cube and you fold it out into a flat 2-dimensional surface, this is what it looks like. I have an illustration to point this out, and I can play this for you. You can see here clearly that we have, what we basically have is a box, and when you unfold the box, and they use a different measurement of course, when you unfold the box, this is what it looks like. So going back to our illustration here, that's exactly what we're talking about. Taking a 3-dimensional polyhedra and folding it out into its flat 2-dimensional shapes that make that drawing to make that polyhedra. We call this right here a net. Okay, and I'll label that for you. Put that label right there. That's called a net. That's called a polyhedron, like we learned in the previous video, episode 26. So I just shrunk these up for you, just so you can see, use them as a reference, but and then what we're going to be doing today is basically, if you look at a problem like this right here, we're going to be working on figuring out how to find the area of all of the surfaces that make up this polyhedron. That one's called a cube. So when it's all folded out, you see all the 3-inch sides. So what I'm going to do here is just looking at this drawing right here, we have all the 3-inch side. We're going to use the area of a rectangle formula, and if you remember that was just length times width, or base times height, remember? So if we do the base times the height on every square, we have, and I can highlight that one for you also, so we have the base of 3 and the height of 3, so 3 times 3 is 9. And these cubes, this cube is made out of all the same the same measurements. So every square that makes up the surface of the cube is 9. And if you count them up, you'd count 1, 2, 3, 4, 5, 6 of those sides that are that are 9-inch, 9 square inches. So if we take 9 times 6, because there are 6 of those, we get 54. So my area is 54. I should say my surface area is 54 square inches. That's how you do surface area. So I have a couple more examples here that we'll do together. I'm going to clear that. I will get rid of these. And here we have an example of this is called a rectangular prism, as I mentioned in the previous video. If you were to fold it out into its net, this is what it would look like. You have your rectangular ends, and then you have 4 rectangular faces. When I say ends, I mean this could be considered the base, and this can be considered a base. And these around here are the faces. So that's those rectangles right there. If you fold this thing out, it could look like this. Now there's more than one way, of course, you could draw that, but here's one representation. Now take our pen and let's start figuring out the area of all of the shapes that makes up this rectangular prism. So if we look at the bottom rectangles, that's this one right here. This bottom right down here is the same as this side right here. And it's a 5 by 4. So we're going to go 5 by 4, and base times height makes that 20. And this is an identical 5 by 4 over here, so that one's going to have to be 20 also. Now, I don't need my measurements right here, really. I already know them. So if they're the same as this one. And then if I go over here and look at my other sides, I'm going to switch to my highlighter here. So this side over here, we'll say, will be the same as this side right here. Okay? And that's a 4 by 10. So that makes this area 4 times 10, which of course means that's 40. And if you look at the opposite side over here, let's highlight that too. The opposite side over on this side over here, see that? There's 2 pink sides. Those are also, that's also 40. So we can put that in right here. That side's 40 also. I guess I could have shaded that in also if you guys like the organizational piece of that. So it'll look like this. These sides are all, those pink sides are 40. Here's my yellow on my other yellow side right here. And that would go along with this top. Okay. And then you got the front and the back. If I'm going to continue to highlight, I'll do it like this. Highlight with, maybe this color isn't the best, but I have this peach front. And you're not going to be able to see it very anymore because I've shaded, but then you have the back side of this thing. And that is a 5 by 10, right? So 5 times 10 basically means that these sides are 50. And now, the next thing I'm going to do, I'm going to erase these numbers to make sure we don't get confused. Now, the next thing I'm going to have to do is what? I have all these areas. Say it with me. We're going to have to add them up, right? So, I'm going to start the easy way. 50 plus 50 is 100. And 40 plus 40 is 80, plus 20 is another 100. So there's 200, and then another 20. And my surface area equals 220. And in this case, we don't know what the measurement is, so we're just going to say units squared. That's how you find surface area of a rectangular prism. Now, the last one we're going to do on this video, because really that's the only ones we need at this point, are 2 samples, is this guy right here. This is called a pyramid, as you probably already know. This has got a rectangular bottom. So we call this a rectangular pyramid. You name the pyramid based on the shape of the bottom. If we were to fold this thing out into its flat surfaces, I can shrink that baby up, it would look something like this right here. So now I need to find the area of all the sides of this rectangular pyramid. Remember, whatever the base, the side that the pyramid is sitting on, whatever that's called, that's how you name the pyramid. So if it's shaped like a triangle down there, it's called a triangular pyramid. If it's a rectangle, it's a rectangular pyramid. If it's a perfect square, you can call it a square pyramid. If it's shaped like an octagon, you can call it an octagonal pyramid. Whatever the base is, that's what the shape, that's what how you name the pyramid. Okay? So, now that we know that, let's go find the area of all the triangles and the one rectangle. As of right now, the rectangle would be the easy one, right? It's a 10 by 4. So that means this one is 40. So that's easy. Not that these all won't be easy. But then we have the skinny triangles on the side over here. That's these. Okay? Those correspond to the skinny ones. And then you have the fatter triangles right here. So let's start with the skinnies. Okay? So I had to make a slight alteration to this problem B right here, because what I noticed is they didn't have heights on those triangles. They had the slope side, but they didn't have the heights. So I changed it. So the height is of the front triangles. Well, I think we were starting with the skinny ones, weren't we? They have a base of 4 and a height of 12. And if we use the formula for area of a triangle, if you remember correctly, let me get my pen tool out. If you remember correctly, formula for the area of a triangle works like this. Area of a triangle equals base times height divided by 2. Okay? So let's find the area of the skinny triangles. Base is 4, height is 12. 4 times 12 is 48. And 48 divided by 2 is 24. So each of the small triangles are 24. And then we got the large triangle in the middle. I mean, the large triangles, there's 2 of those. We have a 10 base by a 12 height. So all we have to do is base times height divided by 2. The base is 10, the height is 12. That's 120 divided by 2 is 60. So each triangle is worth 60. Now what did we do before on the rectangular prism over here? What did we do on this one over here? We added those up. So we can do that quick adding. Start with the easy stuff. 60 and 40 is 100. And then we have 24 and 24 is 48. So we have 148. And then 148 plus 60. 140 plus 60 is 200. Plus 8 more is 208. So my surface area of this rectangular pyramid is 208. And this one's going to be units squared also. So that's a little bit about surface area of different polyhedra. If you have any questions, of course, as usual, you know where to find me.